So the term coterminal. So when you see this word, guys, all this means it's an angle that has the same terminal edge. Okay, now a terminal edge of an angle is where it ended. All right, so for example, on this animation up here, okay, the terminal edge is that red side right there. So if I said, what's an angle that's coterminal with that other than 60 degrees? No. Okay, if you add 360 to that, you go one counterclockwise rotation, that angle, which is 420, is coterminal with 60. All right, if I added 360 two times, 780 is coterminal with 60 degrees. They end at the same place. That's what coterminal angles are. Now, you can also subtract, which means you go clockwise. So a 60-degree angle is coterminal with a negative 300-degree angle. Or a 60-degree angle is coterminal with a negative 660-degree angle. So to get coterminal angles, all you're doing is adding 360 or subtracting 360. Okay? So with degrees, it's very simple. All right? Now, when you get into radians, it gets a little bit more involved. But with angles, with degrees, it's easy peasy. All right, so we'll do the degree ones first, and then we'll go into the rad part. Okay, so if I wanted to get a angle that is coterminal with an angle, with a given angle, then I'm going to either add or subtract 360. So if I had an angle that's 575 and I want it to be the same as an angle between 0 and 360, well, 575 is bigger than 360, so I'm going to have to subtract. Okay, so if I subtract 1 360, then that new angle is going to be coterminal. So these two angles would have the same edge, 215. Okay, and 215 is between 0 and 360, so that's what I want. All right, so if I had an angle that was 1,002 degrees, I just keep subtracting 360 until I get between 0 and 360. Okay, so if I did 1,002, okay, and now I just keep subtracting 360. So nope, gotta keep going. Yep, 282. So this one required 2 counterclockwise rotations to get it down between 0 and 360. Okay, so this is 2 counterclockwise rotations. And when you do that, it unwinds it down to 282. This is 1 counterclockwise rotation. Okay, now if an angle's negative to start with, instead of subtracting 360, you're going to add 360. So now I've got a negative angle. All that means is that when the angle was made, instead of it turning to the left or going clockwise, so when an angle is 60 degrees, or when an angle is positive, folks, it starts here at the blue line and it rotates counterclockwise. Okay, when you put a negative angle in, it just rotates the other direction. So if I put in, let's see, negative 330, okay, negative 330, enter, okay. All right, so that angle, that's what negative 330 looks like. Instead of going clockwise, the blue angle rotates down, or the blue line rotates down. So if I want a coterminal angle, to unwrap that, I'm going to add 360. So if I add one 360 to it, I get a 30-degree angle. So 30 and negative 330 are the same thing. Okay. If I did it twice, negative 330 is the same as 30, or add a 360, or add another 360. These are all these angles up here, the 750, the 390, the 30, the negative 330, the negative 690. Those are all coterminal angles. They all begin, or they all end at the exact same place. Okay, so back to our example here. I want a coterminal between 0 and 360. Where'd you go? Okay, between these two numbers, so I'm going to add 360 here, and that gives me 30 degrees. Easy. And I wanted these answers to be between 0 and 360 so that we can do sines and cosines on them. So if you have an angle that's bigger than 360 and you want to figure out sines and cosines, you got to turn it into an angle that's between. So I wanted these all to be between 0 and 360. Okay, now the reason we do that, we use coterminal angles is, we'll come back to this in a second on this side, is over here. If I gave you, on the next page, it says find the exact value of the sine of 390. So when it says exact value, okay, you're not going sine 390 on your calculator. Okay? Even though that is this would be, we know our answer is going to be 1/2 because of that, but normally you'd get this big long decimal. That's not the exact value. These are exact values. So we got to take that 390 and turn it into one of these angles here. So I want to take the 390 and turn it into one of these three or one of these four angles. These are like the coolest highlighters ever. I stole them from my daughter. It's just a really cool highlighter. It's got a little see-through thing. You can see where you're highlighting.
Oh, that's sick.
It is. Yeah. Okay. All right, so we're going to take this 390 and we're going to change it into a coterminal angle. So 390 is bigger than 360. So if I take that 390 and I subtract 360 from it, I can turn it into an angle that I have on this table. 390 take away 360 is 30. And then all you got to do is look it up on the table. Okay, 30 degrees, sine 1/2. All right, that's not between 0. I want this to be between 0 and 360. Okay, so I'm going to subtract 360 and I get 60. Easy. So cosine of 60, that's on my chart. Cosine, that's also a 1/2. So when the instructions say exact value, you're not typing in decimals. You're typing in these values that we figured out when we did special right triangles. Okay. All right, so now we got a negative number. So to change that to a positive, I'm going to add 360. So this is, guys, the same as the cosecant. And that would be, what, 90? Then I go up here, I find 90, go over to cosecant, and that's 1. All right, and then finally, secant 405. That's too big. So I'm going to subtract 360. And that is 45. And I have an exact value for that. Let's see, 45 secant root 2. Okay, so like I said, degrees is really straightforward. Okay, now when you get into radians, you just gotta, you're doing the same thing. To get a coterminal angle, I'm going to add 360 to this or subtract 360, one of the two. And then that's going to turn that into a coterminal angle. But I can't add or subtract 360 because this is in radians. Okay. All right, so to understand how that works, that's where you got this pie chart here. So grab that. You want to hold on to this because it's helpful for counting. All right. All right, so just look up here first. Let's see. I'm going to have you do a coterminal angle for 23 pi over 4. Okay, what angle is the same as 23 pi over 4? All right, so you go to your circle, that's pi over 4. So pi over 4, guys, that just means the circle is divided. The top half of the circle is 4 slices. The bottom half's 4 slices. So it's 8 slices. So a pi over 4 piece is this big. Okay? So when I count on these, the way you count, this is 0. So you always start here on the right. And if it's a positive angle, you're going to count this direction. So we're going to count, okay, counterclockwise. Right. So turning pi over 4 means you turn like that. A turn that is 2 pi over 4 would be 2 of those. 3 pi over 4, 4 pi, 5, 6, 7, 8 pi over 4 takes you all the way around. So 8 pi over 4 is the same as 360. All right, so here we'll just write, this is pi over 4. This is, well, we can write it like this. 2 pi over 4. Okay, 3 pi over 4, 4 pi over 4, and so on. All right, that's going around the circle one time. So all of these pi over 4s that you see in red are all between 0 and 2 pi. 8 pi over 4 is the same as 2 pi. All right. So this 23 pi over 4 isn't on this list here. And I want to know, where would it be on here? Okay, well, when we got to here, we did 8 of them. So if we went around again, that would be 16 of them. And if we went around again, that would be 24 of them. So that's too much. So I'm going to go around twice, 8, 16. Now I'm going to count up to 23. Okay, 1, 2, 3, 4, 5. Wait a minute, where was I? 16. 17, 18, 19, 20, 21, 22, 23. So 23 pi over 4 is the same as 7 pi over 4. Okay. All right. Let's try one with pi over 3. What would 17 pi over 3 be? If I said, what is a coterminal angle with 17 pi over 3? Okay, so here's your pi over 3's. Yes. Alrighty. So now, as we count, this first term be pi over 3. Okay, and then this guy would be 2 pi over 3. 3 pi over 3 is half the circle. 4 pi over 3. 5 pi over 3. And one time around the circle is 6 pi over 3. Remember, we're counting this direction. Okay, so now where would 17 pi over 3 end up? So you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 pi over 3 is the same as, I think I wrote a 6 there, it's supposed to be a 3, is the same as 5 pi over 3. Okay, or a little bit quicker, one time around is 6, 2 times around is 12, then 13, 14, 15, 16, 17. That's the coterminal angle. Okay. All right, let's do a pi over 6. Let's say 27 pi over 6. 27 pi over 6. Okay, what angle is coterminal with it between 0? We want our answer to be between 0 and 2 pi. So that's the one time around the circle. Okay, so here's your pi over 6's. So 1 pi over 6. And then one time around is 12 pi over 6. And we want 27 of them. Okay. So if we went around one time, that'd be 12. Went around again, that'd be 24, 25, 26, 27. So this is the same as 3 pi over 6. And when you reduce that, it's pi over 2. So pi over 2 and 27 pi over 6, these are called coterminal angles. Okay. Yep. All right. If you did 23 pi over 2. Okay, 23 pi over 2. All right, so pi over 2, cut your pizza into 4 pieces. So here's your start. Okay, we're counting this way. So that's 0, so this is 1, 2, 3, 4 pi over 2. That's the same as going around the circle 360 degrees. So I want to count up to 23. So 4, 8, 12, 16, 20, 21, 22, 23. This would be coterminal with 3 pi over 2. So if we were doing a problem and I said, what's the cosine of 23 pi over 2? You could say, well, that's the same as the cosine of 3 pi over 2. And then you could go to your chart here. There's 3 pi over 2. There's the cosine. Okay, that's why we get these numbers down to between 0 and 2 pi. Okay. All right, and then the last one is if you cut it into pi pieces. So doing half a turn, that's 1 pi. So again, if we started here, and we count this direction, 1 pi is half the circle. Okay, this would be 2 pi. Next time around, this would be 3 pi. This would be 4 pi. Next time around, this would be 5 pi. This would be 6 pi. So if it's an odd, it ends up over on the left. If it's an even, it ends up over on the right. Okay, where's my... Okay, so I'll just squeeze this in. This would be 6 pi. So these are all even pi, and over on this side is all odd pi's. So if I said, what is the sine of 975 pi? Well, that is this angle and this are the same thing. 975 is odd. Odds are going to end up over here. So the sine of 975 pi would be 0. So you're always just changing bigger angles into an angle that we know information about. Okay? A question becomes, what if it's not one of these? Okay, so what if I gave you something like 23 pi over 9? Well, we didn't make one that was cut into 9 pieces. So how would you get this so that it's between 0 and 2 pi? So here was your key. When we did this one, we use, I'll just highlight it. This is what 2 pi is. Okay. This is our value of 2 pi. So remember, 2 pi is the same as 360. Subtracting this is the same as subtracting 360. Subtracting this, same as subtracting 360. So what would it be? What would 360 be in terms of this? Excellent. Very good. 18 pi over 9. That's the same as subtracting 360. Okay, so what is that? 6 pi over 9. Is that between 0 and 2 pi? What is it? 7? No, I can't think. God bless Krolak. That's embarrassing. 5. That's 5 pi over 9. Is 5 pi over 9 between 0 and 2 pi? Yes. Okay? Because 2 pi in the world of 9s is 18 pi over 9. That's smaller. So 23 pi over 9 is coterminal with 5 pi over 9. That's what you're subtracting. Okay? All right, so now that we know that, okay, we want to find the coterminal angle. That's 19 pi over 3. Okay, so we can use the counting method. There's my pi over 3's. So 1 time around is 6, 12, 18, 19. This is where 19 pi over 3 would be. So I know this answer is going to be pi over 3. Okay, now if I didn't have my little chart here to count with, okay, then I know to take away 360, that's the same as subtracting 6 pi over 3. So I'm going to keep subtracting 6 pi over 3 until I have a number smaller than that. So 19 take away 6, that's 13. I want it to be smaller. Okay, 13 take away 6, that's 7. I want it to be smaller. So I got to take away 3 of them, and that gives me pi over 3. So this is, you had to unwind this thing by doing 3 360s. This is 3 counterclockwise rotations. So this thing had to be unwound a whole bunch. Okay. 33 pi over 4. So we'll go chart first, pi over 4. Okay, 1 time around, 8, 16, 24, 32, 1 more, 33. There's my answer. Okay, if I wasn't going to use the circles to count, then I'm going to do this. Subtract 360, which is 8 pi over 4. Let's see, that's 25. Got to keep going. That's 17. That's 9. I got to get below 8. So I got to do 1 more. Whoops. Yep. So it doesn't always work out that it's just the bottom number. Pi over whatever the bottom number is. That's not true. It's like when we did some of these other ones, you'd end up with things where the bottom number is still 9, but the top number isn't just pi. All right. So on this guy, we'd be taking away pi over 6. One rotation is 12 of them. So that would be 25. Take away 12 more. 13. Take away 12 more. 1. So on all the examples I picked, it all worked out that they turned into just 1 over whatever the denominator was. That was by accident. Okay, if you did it using the counting method, 12, remember we're always counting counterclockwise. 12, 24, 36, 37. All right, these next two are really easy. If it's an even pi, it's equal to 0 or 2 pi. If it's an odd pi, it's equal to pi. So this is automatically pi. And this is automatically either, doesn't matter, they're the same. Okay, that's even. That's odd. So no matter what it is, if it's just plain old odd pi, see it's not a fraction, then it's one of these two. Okay, just about done. We got this. Okay, flip that guy over. Now we want to find what these are. Okay. So there is, now I want to turn those guys into these. I want to turn that 9 pi over 4 into one of these. Okay, so pi over 4, that's 8 pi over 4, one more, 9 pi over 4. Okay, so this is the same as the sine of 9 pi over 4, take away 8 pi over 4, which is the sine of pi over 4. And we just look that up on the chart. Okay. Pi over 4, go over to the sine, and there's your answer. So this is root 2 over 2. Okay, 9 pi over 2. 4 pi over 2, 8 pi over 2, 9 pi over 2. So this one would be the same as pi over 2. Oh, thank you. Okay. All right. So go to pi over 2. Go over to the secant column, not defined. Okay, so I just write not defined. There is, it doesn't exist. Does not exist. Okay, 13 pi over 3. One time around 12, or 6, 2 times 12, 13. It's the same as pi over 3. One time around, that's 7. 2 times around, now it's down to pi over 3. Now again, guys, don't always think it's automatically that over. It's just the examples I picked, these always turned out to be 1. I didn't do a really good job on that. But that's not always true. That's not a pattern. Okay, so now, there it is. Go over to tan. There's my answer. Okay. 3. Alright, last one. Okay, 25 pi over 6. So to subtract 360, I subtract 12 pi over 6. So that's 13, so I can take away another one. Go up here, pi over 6. Go over to cosine, and my answer is root 3 over 2. Okay, and that's how we get coterminal angles. And we're going to need to know, you need to know how to do coterminal angles so you can get the next thing we're going to learn, which is called reference angles. So reference angles, you got to know the coterminal angle to get the reference angle. All right, so the assignment for this, guys, I think I made it, let's see, today's Thursday, so Saturday night. This guy right here. So this will be due Saturday night, midnight. So what is that? Today is the 8th, 9th, 10th. Today's the 8th. Oh, God bless. I'm a day late, dollar short. You are right. The 11th.